This is our first mini lecture on the mathematics for engineering. In this instance, we're deriving the heat equation, where this is a rod of length L. Now, our assumptions are that the rod is made of a single homogeneous conducting material, and the rod is laterally insulated. And so heat only flows along the x direction. Now the rod is thin, so the temperature at all points of a cross section is constant. Now if we apply the principle of conservation of heat, the segment x plus delta x, we can claim net charge of heat inside here equals the net flux of heat across the boundaries plus total heat generated inside the interval. Now the total inside the interval is the integral between x and x plus delta x of c rho au of s of t ds, where c is the thermal capacity of the rod, which measures the ability to store heat, and rho is the density of the rod, and a is the cross-sectional area of the rod. We can now write the conservation of energy using calculus as this, which gives us this we will call equation 1, where K is the thermal conductivity of the rod and F x of t equals the external heat source. Now we wish to rewrite this equation 1 so that it does not contain integrals. So for this we can use the mean value theorem from basic calculus. If f of x is a continuous function in interval a and b, then there exists at least one number, epsilon, such that epsilon is bounded between a and b, and that satisfies this here from the mean value theorem. And applying this to equation 1, we arrive at this. So now as we take delta x to 0, we will get a derivative, which is this, of this form, where alpha squared equals k over c rho is called the diffusivity of the rod, and f of xt equals 1 over c rho f of x of t is the heat source density. Where in this case I've switched notation from uxx I've switched the notation here as such as this is the second derivative of u with respect to x, and this I'm going to keep this notation throughout these talks on engineering mathematics. So yeah, please do like and subscribe, there's plenty more to come.